So we'll be skipping section 8.5 and moving straight on to section 8.6, solving rational equations and inequalities. So far all we've been dealing with is simplifying expressions with fractions with variables in the denominator, but now we're going to actually solve them. So the techniques are a little bit different but similar and therefore confusing. Okay, so here is an equation. Look for the equality. You have an equal sign. Now you know an equation, you want to go ahead and solve it. When you're solving equations that have fractions, what you want to do is clear the fractions. You want to get rid of the denominators entirely. And when we were doing expressions, we were finding common denominators and adding and combining and simplifying, but this time we're just going to get rid of the denominators altogether. And the technique we're going to use is similar. We're going to find the least common denominator, and then we're going to multiply each term by that least common denominator, and that way we'll get rid of the fractions altogether. So in this case, the least common denominator is going to be 3 times 4, which is 12. So let's multiply each term, left side and right side, by 12 and see what we get. Okay, so we're going to get 100 minus 4x over 3. We're going to multiply that by 12. 5x plus 6 over 4, multiply that by 12, and then 12 times 6. Now we'll go ahead and cancel where we may. So on the left side, the 12 and the 3, since those are being multiplied, you can cancel and get 4 times 100 minus 4x. And then on the right side, the 12 and the 4 becomes a 3, and so you get 3 times 5x plus 6. And so the rest is just kind of neatly and carefully simplifying, multiplying things out. So we get 400 minus 16x equals 15x plus 18 plus 72. And now we've got to just solve for x. Get the x's on one side, get the numbers on the other side. And when we do that, we find that we get 310 is equal to 31x, or x is equal to 310 over 31, which is 10. Okay, so that is our answer. Now, get in the habit of checking your answers whenever you're solving a rational equation. So we'll plug in 10 for x and see what we get. 100 minus 4 times 10 is 40. Over 3 has got to be equal to 5 times 10 plus 6 over 4 plus 6. Just go ahead and work that out really quickly. We're going to get 60 over 3 is equal to 56 over 4 plus 6. Is that true? Yes, it is. Okay, so it checks. All right, so here is an example. We're going to talk about extraneous solutions. Again, the reason you check is because you might get an extraneous solution. And they typically will come when you have a variable in the denominator. So when you have a number in the denominator, you're not typically going to get one. But when you have variables in the denominator, which is most of the time when we're dealing with solving these equations, you have to check. So let's go ahead. Now, we have x squared minus 3x, x, and x minus 3. Once again, we have to find the least common denominator. Basically, every factor has to be included. It looks like our least common denominator is just going to be, x times x minus 3. So let's just multiply the whole thing. We're going to multiply the whole thing by, well, actually we're going to multiply each term so that we get those common denominators, and then we can clear it. All right, so x times x minus 3 times 3 over x squared minus 3x, and then we're going to go x times x minus 3 times 4 over x, and then x times x minus 3 times 1 over x minus 3. So when we're doing solving these rational equations, we're going to multiply by whatever our least common denominator is, and then we'll go ahead and cancel what we can and simplify. Okay, so you see the left term, it's all of the whole denominator is going to cancel. I mean, the goal is to get rid of the denominator, but the numerator, the multiplier, is also going to cancel. So let's go ahead and work it out. X times x minus 3, x and x cancel, and then x minus 3 and x minus 3 cancel. So now we simplify. I know I'm going fast, so feel free to pause and slow down. Okay, when I solve for x, I find that x is equal to 3. All right, now, just to back up for a second. We found the least common denominator, we multiplied every term by the least common denominator, and then we canceled. The trickiest part in these problems is figuring out what the least common denominator is and then being careful and accounting for the things that cancel and not forgetting anything. But again, we could get an extraneous solution, so let's check to see. We're going to plug in 3 for x and see what we get. So we're going to get 3 over 9 minus 9 plus 4 over 3 equals 1 over 0. And we can see that we get a 0 in the denominator twice, which means that x equals 3 is not a valid solution. So in this case, you would just say there is no solution. All right, inequalities. Okay, rational inequalities are solved by identifying critical points and then finding the regions on the number line that work as solutions. So we basically find the critical points and then we test the range on either side. Okay, so the way we identify the critical points, first we find values where the denominator is 0. Those are critical points. In other words, those cannot be solutions. So wherever we have a 0 in the denominator is a critical point, but it's not going to be a solution. Then we can solve the inequality, just like we solved an equality, and then we're going to test the various regions on our number line. So here we go. 1 over 3x plus 1 over 9x is less than 2/3. Now, oftentimes when you got fractions like these, the checking is the most tedious part, but let's go through it anyway. Okay, so what values will have will have a 0 in the denominator, and that will be true when x is equal to 0. So that's the first thing we realize, is that x cannot be 0. That's one of our critical points. Now let's go ahead and multiply by our least common denominator. In this case, it's going to be 9x. We multiply by 9x every single term. We'll cancel where we can and then simplify. So we get 9x times 1 over 3x, 9x times 2 over 9x. And we set them equal to each other. Now we're just dealing with it as an equality. We're going to solve it, and then that will become one of our critical points. As we solve it, we find that x equals 5/6. Okay, so when we solve the equality, we set it equal, we find that x equals 5/6. Okay, so let's come up with a number line, and we're going to have one point, it's going to be 0, and the other point is going to be 5/6. Now we need to test points to the left of 0, to the right of 0, and to the right of 5/6 to see which regions are valid. So we'll start with testing at x equals 1. So we'll plug in 1 to our function, and we get 1/3 plus 2/9 is less than 2/3. Now once again, you got to find common denominators to make a valid comparison, and we're going to end up showing that 5/9 is less than 6/9, which is true. So the region to the right is valid. Okay, let's try the next one. We're going to test, let's say x equals 1/2. We'll plug those in to x, and we'll get 1 over 3/2 plus 1 over 9/2 equals 2 over 3. I have to simplify those fractions. Remember, you can multiply. When you're dividing, you can multiply by the reciprocal. When we multiply by the reciprocal, 1 over 3/2 becomes 2/3. 2 over 9/2, we'll think 2 times 2/9, which is 4/9, and that's less than 6/9. I'm trying to get close to a common denominator, so I get, let's see, 6/9 plus 4/9 is less than 6/9. And no, that's not going to be true. Okay, so that region is a no. And then let's test to the left of the 0. Let's try with x equals -1. -1/3 minus 2/9 equals 2/3. Is that true? It is true. So that region is true. So then we would finally color it in. And notice we put an open circle at the 0, because remember, 0 is where the denominator becomes 0. And so we can't have that as a solution. So we open that point as an open circle to say that that is not part of the solution set, but that the solution goes right up to the 0. So we'll color in that region, and then we'll go ahead and color in the region to the right as well. And that one can be oops, let me back up, sorry. And that one is also an open circle because we started with a less than sign. So over here we had a less than, not a less than or equal to, so that one is also an open circle. So those are our two regions that are valid solutions. Okay, last problem. Again, we're going to find which values have our denominators go to 0, and then we're going to solve the inequality. So here we go. We know in this case x minus 1 is going to be equal to 0, then x cannot be equal to 1. So there's our first critical point. All right, let's go ahead and solve the inequality. Our least common denominator is going to be 6 times x minus 1. So we're going to multiply each term by that to clear the fractions. So we get 6 times x minus 1 plus 5 times 6x minus 1 over x minus 1. And that's greater than 7/6 times 6 times x minus 1. Okay, so we've set it up. We figured out what our common denominator is. We multiply each term. Now we're going to go ahead and cancel as much as we can and simplify. So I'll get 6x minus 6. The x minus 1's cancel, so I get 30 on the left, and then the 6's cancel, so I get 7x minus 7. From here, I just want to solve for x. Subtract 6x from both sides. Add 7 to both sides, and I get x is equal to 31. So my two critical points I found are at x equals 1 and at x equals 31. So we need to test some points on either side. Let's start with x equals 2. When I plug it in, I check to see what I get. I get 1 over 2 minus 1, 1 plus 5, which is 6. Is that greater than or equal to 7, 6? Yes, it is. So we can say that is a true region. Okay. Then we're going to try x equals 37. I don't know why I picked such a big number, but okay. Oh, I know, because then 36 becomes a least common denominator comparison. When we check that, we plug in the value of 37, we find that it is not true, so that's a no region. Let's go ahead and check to the left. X is equal to 0. That's a little bit easier to check. 1 minus 5 is greater than or equal to 7, 6. That's going to be a negative number. Negative 4 is greater than 7, 6. That's not true. So that one is a no. Now, once again, let's think about how we fill in our regions. At x equals 1, we know that is not a solution because that's where the denominator goes to 0. So that's got to be an open circle. And then 31, since we have now a greater than or equal to sign, we know that that point is included at the end, at the boundary. So our complete region will be open circle at 1 to closed circle at 31. And that completes our lesson.